Welcome everyone, Brian here. Now today what I have for you guys is another video. Today we're going to be solving this interview question or problem. This is the binary search, and essentially is a more efficient and scalable way of searching large arrays, and that's sorted arrays to be exact. This does not work if they're not sorted. Now let's jump into this problem a little bit. So they're giving us two arguments, right? The first one is an array of numbers known as nums, and they're giving us number, which is target. Now essentially they want us to find target in the array nums. Now you may think, well, we could just iterate through each of the values and return whatever index it is, and yeah, that works, and that's a fine solution if you're working with small data sets. But let's say you have an array that is very large. This is not going to work out too nicely in those scenarios. You're gonna be using a lot of memory. It's going to be a lot slower, and it's just not scalable, period. There's better ways to do it, and one of them is known as binary search. Now to start off, we're going to declare two variables. The first one is the left. We're just going to set that to 0, and the second one is our right, and then we're actually going to set that to the length of nums dot length minus 1. And the reason we're subtracting 1 is because it is a 0 based index, so we have to subtract 1 from the length. And we're actually going to iterate through these with a while loop. Now this is going to go on until we say essentially less than or equal to the right side. We're going to be converging on subarrays, and once they both meet at the middle or past each other, that is when we'll know that we haven't found anything in that array, and it's safe to just return -1, because our problem does say otherwise return 1 if you cannot find the target within the num. So it's safe to say that the left passes the right side as we converge in and look for this value. Then it's not in there, so we're just going to return 1. Now the next thing we're going to want to do is keep track of the middle, or the index, and we're just going to call this the pivot, because that is how we'll be pivoting around the subarrays, or defining them. And this pivot is going to be equal to the left side plus the division of the current subarray. And we create the subarray by taking the right side and the left side and subtracting that, and also dividing it by 2. That is how we'll know where the middle's at, and we want to call that the pivot. Now there may be scenarios where we get an odd number, so we're going to want to use a math library and round it down with floor. That way we get a nice and even number, and it's perfectly safe to index with. Now we're going to want to set up a few if statements to catch the different scenarios as we pivot throughout this subarray. So the first one is going to be checking if the target is equal to the current index, which is defined by pivot. If this is true, then we'll know that we find the target already, and we're just going to return the value that pivot has. Not the value, I mean the index. That is the index. Now that's not always going to be the case, so we're going to catch another scenario, and that is if the target is less than the value found using pivot. So let's stop here and really recognize what this means. So our target number is on the left side if this statement is true, our target number is on the left side of the current pivot, the value of that. So that means we're going to continue searching on the left side, and that means we're going to want to reassign our right side. We're essentially creating a subarray within a subarray within a subarray, and the original is a full array. And then we're going to want to set the right to pivot minus 1. And the reason we're doing a -1 is because we've already checked whether the pivot is actually equal to the target, and we know that's not true. So it's fit in this new subarray. It's fine if we just exclude pivot, because we already know pivot is not going to be the target. But there is still another scenario where this is not true, and we're just going to go ahead and catch it completely, and create a new subarray regardless, and that would be by redefining the left side and closing it in from the left side, and that'd be pivot plus 1. Now this means that, we indexed the array using pivot, and we found that the target was on the right side of pivot, and the inverse is true as to why we add or subtract 1, because we already know that pivot is not going to be the target, so it's fine to just exclude it. Now I do believe this is our solution. I'm going to go ahead and run it and see if we got it the first time. Let me just double check my work. Alright, everything looks good. Hopefully I didn't miss anything, but let's go ahead and run it. Now I am using the free LeetCode version, so this might take some time, and we got the solution correct. That is pretty gnarly. So I'm going to go ahead and link this problem down below if you want to check it out for yourself. It should be completely free. Shout out to LeetCode for providing these questions. I'll leave a link to them down below, and let me know if you're able to solve this in a much quicker way. And let's see who comes up with what. And yes, we did use JavaScript. I do know Python. I do know Ruby. I really don't like Java, and C++ is even worse. But maybe next time I'll use one of those languages. Let me know down below, what do you think I should use? And hope you really enjoyed this video, guys. Please give it a like. If you want some more of this content, subscribe. Until next time, peace.